we just ended, same spot we just ended after the tornado drill. So you need to take 6 divided by 0.14. 6 divided by 0.14. 42, close to 42 miles. We're going to go back on our graph. We're going to go up to 6 and see where it crosses. It's close to 42. So that worked out the way we wanted it to. It says sketch the graph of this equation using the same coordinate plane in part E. What do you notice about the graph of all the input and output pairs? We're going to skip that. Moving on. Okay. We have a new equation here. This one is y equals x squared. That's the equation for number 2. Everybody needs to be looking at number 2. New equation, it's y equals x squared. We're going to fill out this table to figure out what y is in all of these different scenarios. So if you take 0 and you square it, what would it be? What is 0 squared? If you don't know, you have a calculator that can do that for you. 0 times 0. All right, what would 1 squared be? 1 times 1. We know what 1 times 1 is. What is it? 2 squared is 2 times 2. 3 squared, 3 times 3. 4 squared, 16. 5 squared, 25. So be filling this in on your notes. 6 squared is 36. So now we're going to graph this. Yours is right below it. I have to actually go to the next one. The first point we're making is at 0, 0. Keep in mind your y-axis is going up by 2, so you've got to really pay attention to your y-axis. If you're trying to plot the point 1, 1, it would be right here, right in the middle, because you can't go up to 2. 1, 1 is right up there in the middle of 1 and 0 and 2. 2, 4, you go over 2, up 4, make a point. Can we pay attention, please, guys? I know they're kind of being loud over there, but we need to pay attention. 3, 9, here's where you go over 3. You could go right in between 8 and 10. That's 9 right here. 4, 16. 5 and 25. And lastly is 6 and all the way up to 36. So this is what our graph looks like. The next question says, what shape does the graph appear to take? Does it look like a straight line? No, what would you call that? We're going to call that, it takes a curve. A curved line. They want to know, boys, can we stop? What's happening? Is the equation a linear equation? Y equals x squared is not linear. The reason I know that this is not linear is because the exponent of 2. Anytime you have an exponent that's bigger than 1, so like if this was a 2, a 3, a 4, a 5, that is not linear. That's your first hint right here. This exponent right here is 2. It says, where's that? Consider the function that assigns each square the side length. Okay, so we have a square. Let's think about this. How do you find the area of a square? This side is S and this side is S. Length times width. So the area would be side times side. You could also say that area would be the same thing as side squared. Because if you take the same thing and multiply it, you can make that an exponent. It's area equals side squared. It says, what do you think the graph of the input-output pairs would look like? So if you had this equation that we just talked about, what do you think the graph would look like? Well, what's the exponent in this little equation? What's the exponent? 2. What was the exponent in the equation we had above that? So it's the exact same. It's going to be the exact same thing. It's going to be a curved line. Because the exponent is 2. Okay, use the function you wrote. So we have area equals side squared. That was the equation that we're using. And it says determine the area of a square with a side length of 2.5. So you're going to say A equals 2.5 squared. So you have a calculator. Type in 2.5 and hit the x squared button. 6 point what? Thank you. So when your side length is 2.5, the area is 6.25. It asks you to write that as an ordered pair. If your side length was 2.5, the area would be 6.25. All right, we're moving on to number 3. The number of devices at a particular manufacturing company that they can produce is a function of the number of hours they spent making it. On average, 4 devices are produced each hour. Assume that the devices are produced at a constant rate. The first thing they want us to do is write an equation. So we're going to start with y divided by x equals. Remember, time goes on the bottom. We're talking about 4 devices in 1 hour. So we're going to put a 1 on the bottom because we're talking about 1 hour. Hopefully you're all writing this down, you guys. 4 devices can be manufactured in 1 hour. So if we're trying to come up with an equation, what number is pointing to y? 1y. What number is pointing to x? You could divide by 1 if you want, but that's not going to change the answer at all. So your equation is y equals 4x. Use the equation that you just wrote to figure out how many devices are produced in 8 hours. So in this case, you're going to take 4 times 8. That's false. Sorry, hold on. No, that's right, 32. So in 8 hours, you can make 32 devices. We're going to make these ordered pairs because we are eventually going to graph them. Then it says in 6 hours, you're going to take 4 times 6. How many devices can you make in 6 hours? Okay, so if we're making an ordered pair, 6 hours goes first, 24 devices goes second. Then we have 4 hours. You're going to take 4 times 4. So in 4 hours, you can make 16 devices. Here's our graph. I'm going to go ahead and remind you of what our points were. The first one was 8, 32. Then we had 6, 24. And then we had 4, 16. So these are the points that I'm going to plot on this graph right here. I'm going to go over 8 and up 32. I'm going to go over 6 and up 24. I'm going to go over 4 and up 16. I'm going to connect my points with a line to see what happens. There we go. So I connected it, and now we're going to answer some questions. What shape does the graph appear to take? It's a straight line. It wants to know, is the function discrete? Yes or no? Is the function discrete or not discrete? Okay, well, let's go back and think about it. We're talking about number of devices you can make and the time it takes to make them. So say you're working at your shop or whatever, you're making, I don't know what they're making, some sort of device. Let's say we talked about 1.5 hours. Could they be working on like a half of something? Like, could they be halfway done with making a device? Yeah. So we're going to call this continuous because you could technically be halfway done and like maybe they didn't finish everything all at, like they didn't completely finish one of the things. Yeah, and then they have to come back to it. So like you're able to do that. So that's going to be continuous because you could do portions of something. I assume you use this equation to describe the function. Where do you think these points would appear on the graph? Any points that work are going to be on the line. So any point that works in this situation is going to fall right on the line that we just drew. What do you think the graph of all input outputs would look like? Well, we think they're going to be a straight line because they have a constant rate. That just means we know how many devices they make every, what was it? 4 devices every hour. That never changes, never slows down, never speeds up. There's a constant rate. I think so. That's okay. We'll just keep going. Okay, it says connect the points. We already did that. Select the point on the graph that has integer coordinates. Verify that it works. So we're going to go back to the graph. I know you guys is on the same page. We're going to go and see in 3 hours what we should get. It says 12. We're going to plug that into our equation. 3 hours, so 4 times 3, 12. So the point would be 312, and that's the exact point we just found on my graph. All right, we're going to talk about how the equation y equals 4x, you could graph this. Is there a y-intercept in this equation? It would be plus what at the end? So that's where it crosses. And this is your slope. That means you go up 4 over 1. Up 4 over 1. Up 4 over 1. So that is the equation of the graph. They're just asking you to sketch that. So we don't actually have to do anything with that letter. All right, this is kind of where we're talking about functions. This is where you need to pay attention. It says, examine the 3 graphs below. Which, if any, could be represented as a function? This is where you guys are going to do this thing called the vertical line test. Vertical line test. So write that up here. Vertical line test. If it passes the vertical line test, it is a function. So what I'm going to do is I'm going to draw a vertical line. Here's my vertical line. I'm going to see if my vertical line ever hits 2 of these points at the exact same time. And when I'm talking about points, I'm talking about the points that they give you right here. I'm highlighting them in red. You can see them. So here is my vertical line. Does it ever cross 2 of these red points at the same time? No, that makes this one a function. We're going to move on to graph 2, and hopefully you'll see I'm drawing a vertical line. You guys can just hold your pencil up vertically, like hold your pencil like this and drag it back and forth. Okay, we're going to drag this over our points and we're going to see, does it ever hit 2 points at the same time? And look right here. Right there, it touches 2 points at the same time. That makes this one not a function. And the reason it's not a function is it hits 2 points at the exact same time on our little graph. And then our last one is graph 3. You guys can use your pencil. I'm just using this vertical line that I drew on my paper. I drag my vertical line across and I see, does it ever cross 2 of these points at the same time? And it does not. That makes this a function. So the vertical line test, if it passes, like it never touches 2 points at the same time, then it is a function. So never touch 2 points at the same time, which means it's a function. All right, those are our notes, so go ahead and put those away.